Now let's read about groundwater. Again, here we are not going to read about groundwater as a resources. We are not going to read about how much groundwater exists, how should we preserve and all. We will not read about that since this chapter is about landform and their evolution. So we will read how groundwater plays an important role in the erosion of land masses and evolution of landforms. We know that initially water goes vertically down in the Earth's surface, and after that the water flows horizontally through the bedding plains. It is this downward and horizontal movement of water which causes the rocks to erode and causes underground caves. Now groundwater contains minerals. When these minerals react with rocks like limestones or dolomites, which are rich in calcium carbonate, it creates a chemical reaction which erodes the rocks and soil, and that is what forms big cracks. They are also known as karst topography. So this is a picture of karst topography. Have a look at this. Now we will read about different types of erosional landforms that exist due to groundwater. The first one is pools, sinkholes, lapiers, and limestone pavements. Now there are 4 words in it. Let me explain each one of them. Let me first explain pools. They are also called as plunge pools. We have read about this few minutes back. Whenever you hear the word plunge pool, immediately think of a waterfall. When water flows over the waterfall, it creates a plunge pool at its base. Due to the force of falling water, it creates a depression at the base. This phenomena is called as plunge pool. Basically, plunge pools are formed by natural force of falling water. The next term is sinkholes. They look something like this. An opening more or less circular at the top and funnel shaped towards the bottom, with sizes varying in area from a few square kilometer to a hectare, and with a depth of less than half a meter to 30 meters or more. Due to the bottom portion being void, the upper surface collapses, forming this kind of a sinkhole. Sinkholes are covered up with soil mantle and appears as shallow water pools. Anybody stepping over such pools would go down like it happens in quicksands in deserts. The term doline is sometimes used to refer the collapsed sinks. The next term is pronounced as lapias. They look like this. Carved, cut, and you can see pits cavity in between the rocks. They are also known as cairn. This feature is formed when water weathers the rock surface. Lapias is found on any soluble rock like limestone, dolomite or gypsum because water reacts with these rocks and forms some chemical reaction in which most of the surface of limestone is eaten away. Now there is this term here called valley sinks. It is also called as uvalas. Let me explain what this is. These are large elongated sinkhole formed by joining several smaller sinkholes. Have a look at this picture. We have read moments back what sinkholes are and how they are formed. They are void at the bottom and the upper surface collapses because it contains soil mantle. It's like quicksands in deserts. They are basically huge depression land. The next term is limestone pavements. Have a look at this picture. This is called as limestone pavement. This kind of landform is also called as karst landform. They are flat, cut into pieces, exposed limestone rocks. If you remember in lapias, the landform is similar to this one, but it's carved, cut, and you can see pits cavity in between the rocks. Over a long period of time, the lapias field eventually turns into somewhat smooth, flat limestone pavements. The second type of groundwater erosional landform is caves. These are underground caves that form because of running water, and they usually occur where there is an alternating bed of rocks. When you dig the surface and reach a sufficient depth, you will find bedrocks, and these bedrocks continue in the form of portions. So alternating bed means if suppose there is a rock bed of shale, and then there is a rock bed of sandstone, and then again there is a rock bed of quartzites, and in between these 3 rock beds you have limestones or dolomites, and these rock beds are dense, massive and thick beds. When water enters the soil, initially it goes vertically down and then starts flowing horizontally through soil planes. After it has reached the rock bed, then water starts to enter the rock through cracks, and groundwater contains mineral and it reacts with rocks like limestone and dolomite and dissolves them. As a result, long, narrow, hollow-like structure called caves are formed. These caves are formed at different heights depending on how thick the limestone and dolomite rock beds are. Now when these caves are formed, of course there has to be an opening, right, through which water gets in. Otherwise, how will it be called as a cave? Likewise, it also has an end through which water moves out. Now, all caves don't have an end. The reason may be they are still in their middle age, where water hasn't eroded the rock enough to create a tunnel. So these were some erosional landforms that occur due to running of groundwater. Now we will read about some depositional landforms, which occur again due to running of groundwater. So basically groundwater is the rainwater that falls on the surface. Now this rainwater is carbonated water, meaning carbon dioxide absorbed water. And limestone rocks contain calcium carbonate, which is easily soluble in carbonated water. Now when water flows through these limestone rocks, water is eroding calcium carbonate and is carrying it in water. These eroded calcium carbonate will get deposited somewhere, because at some point water will evaporate as it moves through rocks and mud surface. So these deposited calcium carbonate is the depositional landform we are interested in, because they also form some structure. And here are some structures that we will read about which are formed by calcium carbonate deposits. The first one is stalactites. These are icicle shaped formation that hangs from the ceiling of a cave. When water drips or leaks from the ceiling of these caves, the minerals in the water, which is calcium carbonate, it precipitates and becomes pointed icicle shaped. Do not mistake them with tips of the glaciers. These are simply groundwater containing minerals of calcium carbonate. The second one is stalagmites. They rise up from the floor of the caves. Have a look at this picture. You can clearly see the difference between stalactites and stalagmites. The third one is pillars. When stalactites that comes from the ceiling and stalagmites that forms from the ground, when they both come in contact, the stalagmite and stalactites eventually merge to give rise to columns and pillars of different diameters. So these were some of the depositional landforms that are formed due to running of groundwater. Just like groundwater, glaciers too are responsible for eroding and depositing of landforms. After all, glaciers are heavy sheet of ice spread over vast piece of plain land area. Even glaciers move, but they move very slow, slower than water. Glaciers are found on plain area, which is at the footstep of the mountains or at the slope of the mountains. Basically, glaciers move with the help of gravity. So there has to be an elevation of the land surface on which the glacier sits. Only then there will be a natural movement, which is due to gravity. Glaciers move a few centimeters to a few meters in a day. Now glaciers erode the surface to a great extent because of friction caused by sheer weight of the ice. When this heavy load of ice moves, of course it will take along massive chunks of rock and soil debris. So I have told you that glaciers reside either at the foot of the mountain or at the slope, where it gets to move with the help of gravity. When a huge sheet of ice moves due to friction, it takes along large chunk of rocks and soil debris. Usually this surface material is in the form of large angular shaped block. That means almost a big piece of land gets dragged along by glaciers. Just imagine the power of glaciers. It has the power to reduce high mountains into low hills and plains. As glaciers continue to move, the slope of the mountains is reduced to such an extent that glaciers will stop moving, leaving only a mass of low hills. Now we will read about the types of erosional landforms that are caused by glacier. The first one is cirque. It is a valley formed by glacial erosion. It is the most common landforms in glaciated mountains. The cirques quite often are found at the heads of glacial valleys. When the ice slowly moves down the slope of the mountain, the accumulated ice cuts these slope in a cup shape called cirques. A lake of water can be seen quite often within the cirques after the glaciers disappears. This lake is called Tarn Lake. The second type of landform is horns and serrated ridges. Horns are these peaks, and these peaks are formed when there are three or more cirques meet. We just read about what cirques are. They are these cup-shaped cuts in the valley. If there are three or more cup-shaped cuts in all directions, naturally the top portion of the valley gets sharper and forms into a peak. This is what is called as horns. And serrated ridges are these narrow zigzag walls on the cirques. After all, a ridge is a long narrow raised portion of land. So the wall between two cirques is a long narrow raised border. This is what is called as serrated ridges. The third type of landform is glacial valleys, or we call it as troughs. Now glacial troughs or valleys are U-shaped broad floors that are carved out by glaciers that have since disappeared. Its sides are very steep, meaning very high, because the moving glaciers grind into the base and sides of the valley over a long period of time and simply cuts it into a sharp edgy steep wall. On the side of the main valley, there are smaller valleys which feeds into the main valley. This side valley is called tributary valleys. The main valley is eroded more quickly and deeper than the tributary valleys. This leaves the tributary valleys at a much higher level than that of the main valley. The tributary valleys are then called hanging valleys and often end in spectacular waterfalls which flow into the main valley. It's really fascinating to know that so much nature's movements have been well documented in books for educating us. Isn't that amazing? It is, right? Anyways, now we'll read about some depositional landforms that exist due to glaciers. You must be wondering how glaciers help in deposition. After all, glaciers are ice. They melt, they convert into water, and they move on. But then fine debris of rocks in the form of sediments are found in the glaciers. They are called glacial till. Now when glaciers melt, you must have seen small streams of water flowing at the bottom or lower ends of the glacier. In this stream, rock debris are carried and deposited. These rock debris are also called glaciofluvial deposits. And there's another term to it called outwash deposits. These outwash deposits are somewhat round at their edges. And the reason it is like that is due to the continuous running water. The continuous force of running water makes the edges of the rock smooth. So that's how depositional landforms exist due to glaciers. So now we'll read about some depositional landforms that exist due to glaciers. The first one is moraines. We have read what are glacial tills. They are rock debris or sediments that exist in the glaciers. And when glacier melts, these debris gets washed away and gets deposited. These sediments or glacial tills form long ridges. A ridge is a long, narrow, uplifted land surface. There are three types of moraines. You can see them in this illustration. One is medial moraine, and then we have lateral moraine and terminal moraine. The second type of depositional landform that exists due to glaciers is eskers. When glaciers melt in summer, the water flows on the surface of the ice, or flows from the bottom portion of the ice, or even moves through holes in the ice. These waters accumulate beneath the glacier and flow like streams in a channel beneath the ice. When this stream flows over the ground, it carries materials like boulder and blocks and some rock debris along with it. This all-coarse material gets deposited along the bank in the form of a ridge. This ridge is called esker. The third type of depositional landform that exists due to glaciers is outwash plains. It is a plain formed of glacial sediments deposited by melting water. These are found at the foot of the glacial mountains. These plains are covered with glaciofluvial deposits. And the fourth type of depositional landform that exists due to glaciers is drumlins. Drumlins are smooth, oval-shaped ridge-like features, composed mainly of glacial till, that is sediment that exists in glaciers. They may measure up to 1 kilometer in length and 30 meter or so in height. I'll show you with the help of an illustration. It looks like an elongated hill in the shape of an inverted spoon or half-buried egg. Usually glacier melts and moves in a particular direction. From side view it looks like this, and from top it looks like this. I hope you can see the direction of ice flow. As you can see, there is a blunt end and then there is a tail. Drumlins give an indication of direction of glacier movement. So this is what is drumlin and its movement. Now we will read about waves and currents, which are also exogenic forces that is responsible for erosion and deposition of landforms. When we see the words waves and currents, immediately sea and ocean comes into mind. And where do these waves and currents come and hit? Coastal areas. That's why the land formation at the coastal areas are the most dynamic and destructive. Erosion and deposition is so fast at coastal place because of constant arrival of waves. When waves break, water is thrown with great force onto the shore, and this mechanism moves the sediments at coastal area to a great extent. That's what makes the coastal landform very dynamic. To understand the coastal landform, we will have to understand two types of coastline. One is low, smooth and gently sloping sedimentary coast, which is also known as emergent coastline, and the second one is high rocky coast, which is also known as submerged coastline. I'll explain both of them. The first one is high rocky coast, which is also known as submerged coastline. By submerged, we get a hint that this coastline is totally under the water. Have a look at this picture. You can see these high cliffs. If you jump into this water, it's not going to be very deep because the coastline is under the water. And why is it so? Because here the sea level is higher. So in a submerged coastline, the landform is under water. Here rapid erosion takes place. Waves constantly hit the cliffs, eroding it and leaving a wave-cut platform. The material which falls off and removed from the sea cliffs gradually break into smaller fragments. They get deposited in the offshore. As the erosion along the coast takes place, a good supply material becomes available to longshore currents and waves. Longshore currents is an ocean current that moves parallel to the shore. These longshore currents deposit materials as beaches along the shore and as bars. Bars are submerged features, and when bars show up above the water, they are called barrier bars. You can see it in this picture. This is a barrier bar. Similarly, sand spit also gets developed, which is connected to the headland bay. Now these barrier bars and spit together blocks the mouth of a bay, and that's how lagoons are formed. So without barrier bars and spits, this area is called as bay. Now with its presence, it is called as lagoon. Then with time, this lagoon gets filled up with sediments from the land, giving rise to a coastal plain. The second type of coast is the low sedimentary coasts. These are your perfect beach where you love to go. The coastline appears smooth. In between you may find lagoons and tidal creeks. These are tidal creeks. They occur due to high and heavy tides, bringing the water onto the land portion. In low sediment coast, the land slowly and gently slopes into the water. Then you will also find marshes and swamps. Sundarban Delta is a good example. It's a coastal plain, then there are swamps and marshes. Now try to understand this. Here you can see the coastline which is slowly going inside the water, and there is a slope. This slope area contains a lot of sediments. When waves hit these sediments, they churn and they move rapidly. Because of their movement, barrier bars, spits and lagoons are formed. I've told you what lagoons are. It is these lagoons that later on turn into swamps and eventually gets filled up with sediments to form coastal plain. Now this entire process in land formation depends on how quickly the rock material are supplied. If at all there is a storm or a tsunami wave, that causes drastic changes because of the sheer power of water. And large river brings a lot of sediment particles along with itself, and when rivers merge with sea or ocean, deltas are formed along these low sedimentary coasts. So in India, the western coastline is high rocky coast, because here the continental shelf is not wide, and the coastal strip is also not wide. But on the other hand, the eastern coastline is a low sedimentary coast, because here the continental shelf is much wider and the coastal strip is very wide. Now we will read about some erosional landforms that exist due to waves and currents. The first one is cliffs, terraces, caves and stacks. We will quickly understand these four words. By cliff we mean sea cliffs, and terraces are forms that are usually found where erosion is extreme. A sea cliff is a steep coastal slope. It is created by massive power of the waves. Waves constantly hit the cliffs and make them steeper. Now at the foot of such cliffs there may be a flat or gently sloping platform covered by rock debris. These debris are part of the cliff. When wave hits the cliff, smaller chunks of rock break and they form a terrace sort of a landform. It is called as wave cut terrace. Now as I've said, waves constantly hit the foot of the cliff with immense power. Now the rock debris that are there, they also get smashed against the cliff. Now this constant process creates a crack in the cliff. Then this crack becomes larger and forms a cave. Then the roof of the cave collapses, bringing the top portion of cliff down. Now this process isolates a tall stack of rock. This is also called as sea stacks. Like all other features, sea stacks are also temporary. They will disappear. Coastal hills and cliffs all will disappear because of wave erosion, giving rise to narrow coastal plains. And then, not to forget, rivers will carry alluvial deposits from the land surface, and it all gets deposited at the coast before the river meets the sea or ocean. And this is how landforms like big cliffs gets eroded into coastal plains to form a beach. Now we will read about some depositional landforms that exist due to waves and currents. In this category we have beaches and dunes. First, let's talk about beach. On a beach you will find sand. So that itself is a proof that beaches are depositional landforms. So where does this sand comes from? Most of the sand comes from the land carried by the streams and rivers when they meet the sea or ocean. And even the sea waves, when they hit the land surface, they bring sand along with it. And over time layers and layers of sediments are deposited. There are some beaches that have excess of pebbles instead of pure sand. These are called shingle beach. Now just behind the main beach, you will find piles of sand is accumulated in the form of a ridge and uplifted narrow landform. This is called as sand dunes of beach, not the deserts. These are very common in low sedimentary coast. It looks like a very tiny hill. The second depositional landforms are bars, barriers and spits. The first one is bars. Bars are a ridge of sand, meaning they are long, narrow, uplifted piece of landform, totally made up of sand. They are formed in the sea, usually at some distance not very far from the shore. From top it looks like this. This is also called as offshore bar. They are parallel to the coast. Now this offshore bar is not so much outside the water. It is submerged. From top you will see a rough patch of sand in the sea because the water is shallow in this part. So what I'm trying to say is, if this offshore bar is outside the sea, meaning if there is a lot of sand and it is enough that it is making it visible outside the sea, in that case it is termed as a barrier bar, because now that it's out of the water it acts like a barrier. Sometimes these barrier bars get attached to one side of the coast. Then they are called spits. Sometimes this spit gradually extends and tries to meet the other end of the bay. So this region is called a bay. Bay is a broad inlet of the sea where the land curves inwards. When the spit tries to meet the other end of the bay, now this region of water is called as lagoon. Even this lagoon gets filled up gradually by sediments coming from the land and from the beach itself. It turns into a coastal plain. This offshore bar we read about, it also acts as a defense against storm or tsunami by absorbing most of the destructive force. So these are in a way a good thing. You see how nature's creation acts both as a protector as well as a destroyer. Now we will read about the last topic of this chapter, winds. Winds are exogenic agents that contribute heavily in erosion as well as deposition of many landforms. Wind is one of the two dominant agents in hot deserts. The other one is the heat due to the sun. Now when the surface of the desert gets heated up, it also heats up the air in the environment. Hot light air moves up in the atmosphere. If you see, low pressure and high pressure works like this. Up in the atmosphere, there's a cool breeze of air moving constantly. That's why as you go up, temperature decreases. Now this warm air of the desert goes up and gets in contact with the cool air. Suddenly there is a change in the airflow. This is what causes turbulence. This change in the airflow can also cause whirlwind, because ultimately everything comes down to the velocity, that is speed of the wind. If the speed is high, it will move the sand particles and will go on to deflate a landform, meaning erode a landform. The wind action creates a number of interesting erosional and depositional features in the deserts. In fact, many features of deserts like sand dunes, mushroom rocks, etc. are formed due to the movement of wind. Deserts rarely face rain, but when they do, it's for short period and it is very heavy. That means the debris of rocks and sand in desert is moved by not only wind but also by rain. The wind moves fine material and general mass erosion is accomplished mainly through rain. Stream channels in desert areas are broad, smooth and indefinite and flow for a brief time after rain. One good example is the river Luni in Rajasthan. This river has hardly any water, but when it rains, it causes flood. Now we will read about some erosional landforms that exist due to winds, and all these landforms exist in deserts. The first one is pediments and pediplains. So what are pediments? These are basically rocks that are just above the earth's surface, and they are not covered with soil debris. They are usually found at the foot of the mountain. They are very much attached to the bedrock. That's why mountains get eroded, but these pediments are visible. Now pediplain on the other hand is an eroded plain that has formed when mountains were leveled by wind and heavy rain activities. So you remember orogenic stage, where mountains are formed when two tectonic plates converge. After the mountains are formed, it gets continuously eroded by wind and water. And there will be a time when these mountains transforms or recedes into plateau stage. It is again further reduced to a low featureless plains called pediplains. The second type of landform that gets eroded due to wind activities is playas. Playas are basically shallow lake that exist in deserts. Here the water is retained only for short duration due to evaporation, and quite often the playas contain good deposition of salts. And when this shallow lake, which is playas, dries out, it gets covered by salt, and then it is called as alkali flats. The third type of erosional landform is deflation hollows and caves. We know that rocks are basically small chunks of soil debris that are packed together. Now the work of exogenic agents is to blow and break the rocks into tiny debris. I mean, that's what we have been studying from the beginning in this chapter. Now this heavy continuous movement of wind currents in one direction creates a shallow depression. These depressions are called deflation hollows. In other words, these are cavities or small pits in the rock surface. With more and more intense blowing of wind and also with time, these pits or cavities become bigger, deeper and wider. They turn into caves. The fourth type of erosional landform is mushroom, table and pedestal rocks. So mushroom rocks looks like this. They are also called pedestal rocks, meaning it looks as if it is standing on a pedestal or a stand. If you see their top surface, it is broad like a table, and the lower portion is thin, which is because of erosion. Basically, once upon a time, this was a big piece of rock. And if we look at rocks closely, they are in the form of layers, and these layers have different mineral composition. Some layers have softer rock, which is capable of blowing away with heavy wind. And that softer rock happens to be at the lower portion. And that's why the upper portion is broad and lower one is thin. Now let's get to know some depositional landforms that are made by winds. We have read moments back that depending on the speed of wind, different sizes of sand grains are moved from one place to another. So that makes wind a good sorting agent. And when the speed of wind slows down, sand begins to settle down at different ranges. It is this phenomena that gives rise to some features, and we call them depositional features. One such feature is called sand dunes. We will find sand dunes in deserts. So depending on the direction of the wind, sand dunes take their shape. By looking at the shape of sand dunes, we can easily find out the direction of winds. The second depositional feature is birchens. Now birchens are also sand dunes, but they are crescent shaped, curved shaped just like a moon. It occurs in sandy deserts all over the world. There is another sand dune called parabolic dunes. Parabolic dunes are formed when sandy surfaces are partially covered with vegetation. That means parabolic dunes are reversed birchens, with wind direction being the same. There is one more dune which is called seef. Seef is similar to birchen with a small difference. Seef has only one wing or point. Have a look at this pic. This is what seef looks like. This happens when there is a shift in wind condition. Then there is longitudinal dunes. Longitudinal dunes form when supply of sand is poor and wind direction is constant. They appear as long ridges but low in height. Then there is transverse dunes. Transverse dunes are perpendicular to wind direction. These dunes are formed when the wind direction is constant and the sand is at right angle position to the wind direction. They may be very long and low in height. Again, all these type of dunes are temporary landforms. They change with time, and that's the whole point of this chapter, that nothing is permanent. No physical feature on this earth is permanent. They all go through series of changes and vanish with time and again re-emerges. It's a cycle that takes place over millions of years. There's constant change that goes on both inside as well as outside the earth's surface. With this, we have come to an end of this long chapter. I hope you have found this video useful. Thanks for watching, and I'll see you in the next one.